Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So all the NEET 2027 aspirants, firstly, how are you all? And today we are going to start with finally class. I would say firstly we're going to focus about your class 12 syllabus, right? And class 11 syllabus, I'm going to take the that in at 6 p.m. right? So now at 6 p.m., right, if you want to cover your class 11 backlogs, everything in detail, that is there. But at 8 p.m., I'll be covering your 12th class chemistry, right? Okay, everybody, if that is clear to everybody, then let me know. And also, where is your energy? Where is your Josh, right? So today what we are going to do is concentration terms. We all know that before starting solution chapter, concentration term is a must do thing, right? Because that forms the base of your solution chapter. You will see this mole fraction, molarity everywhere throughout the solution chapter, right? Concentration terms you have also discussed in class 11th, right, in some basic concepts of chemistry, right? And in class 12th also, you will again discuss this in detail directly in the solution chapter. After this class, I'm going to start with solution chapter. So before that, this class was very necessary for all of you, right? Yes. Okay, I am also fine. I am perfectly fine, students. So I want to see your energy in the chat box. I want to see that how excited you are to, how enthusiastic you are to complete your syllabus with us, right? Do you want to actually deep dive into chemistry and learn all the concepts along with the NEET questions, right? I'll also provide you with the previous year questions here, right? We'll also do some practice here, right, in this session itself. And notes will be provided to you in the description box. You will see the PDF link, right? Just click on that, you will get the PDF, right? Okay, yes. So let us start this. But before that, let me inform to all the students out there who are preparing for NEET 2026, NEET 2027. Guys, right now at this point, Vedantu is offering you IV SAT scholarship program. That is, you can get out around 90% scholarship here, right? You can avail up to 90% scholarship depending upon your results, depending upon your marks, right? But for that, first you have to give this test. And now, how can I give this test? You just need to click in the description, right? You will get the link of IV SAT, right? Register yourself to that. Give the test in offline or online manner. I would advise you to give the test in the offline manner so that you can also understand what kind of education is there. You can meet your teachers, you can meet your counselors, right? And then you can get up to 90% scholarship. And here, right, if you're a dropper and you're like, okay, what if still I'm not able to improve my rank, then we are giving you this guarantee that your rank will be improved. Otherwise 100% refund we will do, and very rare institutes provide these kind of guarantees, right? So you can see like where is your offline center, ma'am? Near my house. You can see Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, and Uttar Pradesh. Okay, all over India, you can see the centers, the cities here, right? PDF I will provide you. You can locate yourself, right? Okay, yes. Now let us start. And those who are new to this channel, let me just firstly introduce myself. I am Diksha Kaushal, your chemistry master teacher, and I'm BSc MSc in chemistry, and I teach physical, organic, inorganic chemistry, right? All of these things, right? I'll polish all of this because I know how interrelated these are to each other, right? And one more thing that students usually say that, ma'am, I am not good in chemistry, right? What to do? What you have to do is attend the lectures daily, make the notes daily. If I give you any homework, you have to do the homework. That's your part, right? Rest of the things I'll do, right? That is teaching you very nicely so that that can get into your head. What you have to do is don't spam in the chat box, right? Be attentive in the class and interact in the chat box. If I ask you something, try to answer, right? Whether you answer it wrong or right doesn't matter. You have to answer something that, okay, this is fine, this is this, right? Answer whatever you know, right? So that even I can interact with you, because we are not robots, we all are humans, right? We need interaction with each other. So let's interact and build this foundation of chemistry so that we can actually get 180 out of 180 in chemistry. That is possible. That is actually possible. But for that, you really need to have consistency, right? That's why we are giving you these lectures every Monday to Saturday. Reason being, consistency should be there. And I'll see you all at 8 p.m., right? Or at alternate days, I'll see you, right? So, first thing is, if you talk about mass percentage, right? So, firstly, we are going to talk about the percentage, right? For that, you tell me one thing. Students, if I talk about the percentage, let's see, I talk about the percentage. Can you tell me, whenever you calculate the percentage of anything, what you do? You calculate the percentage of anything, right? What you do? Percentage of anything. Anybody? Percentage of anything is calculated by multiplying it by 100. Now, four kind of percentages you can have. Four kind of percentages you can have. First is weight and volume. We will play with weight and volume, right? First, we can put it as weight by weight. Next, we can put as volume by volume. Then you can put weight by volume, and then you could put volume by weight, right? Now, always remember, whenever you calculate percentage or ppm, always do solute by solution. Solute by solution multiplied by 100, right? Solute by solution multiplied by 100. Whether we are talking about weight by weight, that will be weight of solute by weight of solution multiplied by 100, right? So one by one, I'm going to write all the answers here. This is weight of solute. Now one more thing. Whenever, what is a solute? What is a solvent? A solute is something which is less in quantity. A solution is something which, a solvent is something which is more in quantity. For example, you have a glass of water, right? You add sugar into it. That small quantity is called solute, and the large quantity is called solvent. And when you mix these two together, then we make a solution, right? Now we will always represent solute by 2, right? I'll always represent solute by 2 in the formulas, and solution is not represented by anything. So I would rather write it here, right? Somewhere here I can make a line here, and I can write here that always solute is represented by which thing? Everybody in the chat box. Solute is represented by 1 or 2. Solvent is represented by what? This is not like you have to represent it like that, right? To make things easy, in most of the books you will see this, right? So solute, and in my formulas also you will see solute is represented by 2 and solvent is represented by 1, right? Now when I'm writing it here, right, weight by weight, so that will be weight of solute divided by weight of solution, right, multiplied by 100. Volume by volume, that is volume of solute divided by volume of solution multiplied by 100. Weight by volume, that is going to be weight of solute divided by volume multiplied by 100, right? And the last one is volume of solute divided by weight of solution multiplied by 100. So what we have done, solute by solution multiplied by 100 always. And whatever is given to you, according to that, you can put weight by weight, volume by volume, weight by volume, or volume by weight, right? Do you need to cram this formula? Tell me in the chat box. Now, if you see, ma'am, then what will be the units here? So always remember the weight. In physics, weight and mass is different, but in chemistry, we ignore gravitation. And it's like we ignore gravitation because we are talking about microscopic particles, right? So we can ignore that. So that's why weight and mass is the same thing, right? So weight is calculated in grams and volume you will see in milliliters, right? Here weight is in grams and grams, milliliter. This is grams by volume, gram by milliliter. This is volume is in milliliter and this is in grams. Okay, understood? 4 formulas we have done by this one single chart. 4 formulas we have done. If that is clear to everybody, then let me know in the chat box. If that is clear, students, then let me know in the chat box. Yes, Yajani, Renuka, Linson, Timothy, Kadi, Uda. Let me know in the chat box if that is clear to everybody. And if you want, if you like, ma'am, let's ma'am make the class interesting. If you don't reply, right, then how can I talk to myself? Tell me one thing, right? Is this a podcast going on, right? Or what? Or is this a Instagram reel where I should talk to myself? Okay, yes, okay, no, no, right? So I need your interaction, right? If you want me to teach, then I need, either you tell me that, ma'am, please don't teach, right? I will not teach, right? If you want me to teach here, right? In DNA batch, I am teaching already, right? If you want me to teach here as well on YouTube, because when I was not teaching, you guys were asking, right? Now I am here. Now what I want from you is interaction, right? This is what I told you. In DNA batch, I don't have to ask it again and again and again. Guys, have you understood? Right? Students are interactive there, right? So if you want to make session good, interactive, energetic, you also have to give something. You also have to contribute a little bit here. And the contribution is simple. You have to interact here. You have to tell me. Otherwise, I'll speed up the class and I will not be able to know whether you understood that or not. And that's not how I teach. Right? Okay? Yes. Now, let us see this here. Only 2 students are able to understand. Only 3 students are able to, only 4. That's it. Out of this, only 4 students understood this. Rest of the students are not able to understand this. Is it? What is percentage? Solute by solvent multiplied by 100 because of percentage, right? This is W2 by W, volume by volume, weight by volume, and volume by weight, right? Now, let's decode this one by one. Okay, we will try to decode this one by one. Firstly, I am going to decode, let's say, mass percentage here, right? Mass percentage is nothing but they are talking about W by W percentage. That is weight percentage, right? Now, decode means what, ma'am? Decode means you just don't need to know the formula. Formula is they don't ask mass percentage in the formulas. You're not in 9th class, right? So, this will be useful in the questions, right? So in the questions, what you need to do, you need to decode these things. For example, they have given you, let's take an example here, only 20% weight by weight of sugar solution, right? 20% weight by weight of sugar solution is given to you. Sugar solution. Let's see what we can decode from here, right? Let's see that. First is 20% means, can I say that whenever they give you percentage, right, what you have to assume, because see, in the formula it is weight of solute by solvent. Always you take the denominator as 100. Always take it as 100. Always take this thing as 100. And out of this, whatever is the percentage that is given to you in the question, that will be the what is given in the numerator, right? So if I see this here, if I say 20, then can I say weight by weight is nothing but weight of solute by weight of solution, weight of solution multiplied by 100. Now, how can I solve this? Whatever is given to you here, right, you will take this as 100. Okay, so this I'll take it as 100. Because here percentage is given to be 20%, then this will become 20, right? So I can say that here weight of solute is 20 grams. Weight of solution I have taken, we have assumed it to be 100 grams. Then weight of solvent is going to be 80 grams, that is 100 minus 20. Got it? So what we are doing here, we are decoding this thing, that what is weight by weight percentage. If they have given you this percentage, they are indirectly telling you the weight of solute, weight of solution, weight of solvent. All of these things you can calculate for just this one thing, right? Okay, that is clear to everybody, right? Now, let us see volume percentage here, right? Volume percentage means what? Volume by volume percentage, right? Volume percentage means we are talking about volume by volume percentage. Now here also you need to decode, because the formula, you know, volume of solute by volume of solution multiplied by 100, that we know, right? Now you need to learn how to decode. Okay, so I am giving you one example here. You have 40% of ethanol in water. Ethanol in water. 40% is given to you. Now, can you tell me what is the volume of solvent here? What is the volume of water here? Let's see. As I told you, whenever 40%, you will take this thing as volume of solution, you will take it as 100 milliliter, because I told you that volume you will always calculate it in milliliter, right? This is taken as 100 milliliter. That means volume of solute will be this percentage, that is 40 milliliter, right? So can you say that volume of solute is given to be 40 milliliter. Volume of solution we have assumed to be 100 milliliter. Then volume of solvent is going to be 100 minus 40, that is 60 milliliter, right? How many of you are able to decode this thing here, right? When you will use all these things in colligative property in solution chapter, then this will be very useful to you, right? Because they will not give you that this is weight of solute, weight of solvent. They will indirectly give you this thing with the help of this percentage. Then you have to do it yourself, right? Okay. So that is how they can make the question little bit tricky, right? Okay. Understood, everybody? Understood? 60%, definitely that is 60 milliliter is the correct answer here, right? Okay. Shall I move to the next part here? Next part, mass by volume percentage. Mass by volume, students. Let's see, here they have given weight by mass by volume percentage, means this thing is given to us. Easy formula is weight of solute by volume of solution multiplied by 100, you can see, or you can say mass of solute by total volume of the solution, that is mass of solute by volume of the solution, right, in multiplied by 100. Now, what if they give you, example is 15% weight by volume percentage of solute. Now you tell me what is going to be the, what all we can decode from here, right? Simple thing, what all we can decode here, I want to see that in the comment section. What will be the weight of solute? What is going to be the weight of solvent? What is going to be the volume, weight of solution? Similarly, you have to tell me the volume, weight and volume. Volume of solute, volume of solvent, volume of solution. Okay, let's see who is going to answer this. Let's see who is going to answer this, everybody. Very good aspirant, very good Uda, very good PPM. PPM also we will discuss, right? Very good. Very good Shiti, Hema, Shabash, very good. Okay. Parts per million. Don't worry, we will discuss this. The next thing is going to be parts per million only, right? Okay. So, if you see this 15% weight by volume, that means I can say that if I see this, if I can calculate, if I just write it here, because I always told you the one that is in the division, that will be taken as 100. So, this will be taken as 100 milliliter. This will be taken as the percentage that is given to be 15. But is this in milliliter? No, this is weight, so it will be in gram. So we can say that they are saying that 15 gram of solute in 100 milliliter of solution. That means you can say weight of solute is going to be 15 gram and volume of solution is going to be 100 milliliter. Ma'am, can we calculate weight of solvent from here? No. Can we calculate weight of solution from here? No, we can't calculate because we have assumed the volume to be 100 milliliter, right? So we can't say that weight of solution is 100 grams. No, we can't say that, right? So here we are talking about weight of solute and volume of solution. That's it. You don't know anything else here. You can't decode anything else here. Got it? Clear to everybody? Some students, they also write weight of solvent is this, weight of solution is this. No, you can't decode when these two things are different, right? You can only tell about weight of solute and volume of solution, right? Is that clear to everybody? Shall I move ahead, everybody? Is that clear? Okay. Next topic that you were talking about, parts per million. Let's talk about parts per million, right? Parts per million. See, let's talk about percentage. Firstly, tell me why percentage is multiplied by 100? Because we are saying per means division, like in how much amount you are calculating. Cent means 100. Cent means 100. That's why we multiply it by 100. That is the meaning of percentage. Now, let's talk about what is parts per million. That means in how much amount you are calculating in 1 million. And tell me, beta, if someone has 1 million Instagram followers, that means how many Instagram followers they have? If someone has 1 million Instagram followers, then how many Instagram followers we are talking about? 110 raised to power 6. That means 1,000,000. That is 1 million, right? So that means we have to, everything is same here. Same as this, okay? I'll just copy paste that slide. You will see everything is same, okay? I'll just copy paste that slide and I'll move it here, okay? Now, if I tell you, yes, okay, what you have to change, everything is same, right? Let's change, this is also same, this is also same. In this case, instead of this, what you have, you have parts per million, right? Instead of this, what you have parts per million, that is ppm, right? Now, what is the difference here that you will see? Instead of multiplying it by 100, we will multiply this by 10 raised to power 6. That's the only difference we have. Okay, we will multiply it by 10 raised to power 6. That's it. Everything else is same. Right? Weight by weight, weight by volume, volume by volume, and volume by weight. Everything is there, right? Weight by volume, everything is there, right? The only difference between percentage and parts per million is you are calculating, let's say you have 100 chocolates, out of 100 you are calculating, right? But in million, you're calculating that you have million of followers. Let's say someone has 100 followers, okay? And they are discussing that out of this 100, how many are girls and how many are boys, okay? Now, someone has 1 million followers. They will talk about parts per million because they have million followers. So they will talk that in this million followers, how many girls and how many boys they are. Okay, understood this concept? Now, see one thing, ma'am, why we need to calculate in million, right? Where is this need? So, in our atmosphere, in our environment, right, you have only 0.03% of carbon dioxide. That is very low amount, right? So that's why the cases where the percentage is very less, right? In that case, let's say you have big amount of something, right? You have, let's say, you have one ocean, right? In ocean, you know that so much water is there, right? Even if you talk about one simple lake also, there is so much water, right? Now you add 1 tablespoon of salt into it. That is parts per million because you are adding very small amount to a very big thing. So when the solvent is extremely high as compared to solute, then we say that it is parts per million. Okay, understood everybody? If the concept of parts per million and percentage is clear to everybody, then let me know in the comment section so that we can discuss with some questions here. Okay, everybody? So that we can discuss some questions here. Now, first is, in a urea contains, if a urea contains 45% by mass N2, okay, N2 is 45%, okay, what is the actual urea content in the sample? Right? They are asking that N2 is here 2 atoms, right? That means one urea molecule has 2 nitrogen atoms, right? They are discussing about N2 here, right? So in one urea, you have one N2 only. In one molecule of urea, you will have one N2 only. That means if a urea, this contains 45% by mass N2, what is the actual urea content in the sample? So you can relate it with the molar mass also, right? So let's see how we are going to do it, right? First is, let us consider 100 kilogram sample of urea. This you can consider, this is taken an example, right? Then you can consider that 100 kilogram sample of urea, right? This is said to contain 45 kilogram of nitrogen, right? Ma'am, can I take it in gram? Yes, you can take it, you will get the same answer, right? Now, 60 kilogram of urea contains 28 kilogram of N2. That means we are saying that we are actually comparing this with the molar mass, right? That 60 is the molar mass of urea, right? 60 is the 60 gram is the molar mass, but you can also write it in kilograms if you multiply it by 1000, right? So this is the molar mass of N2, right? Now, after this, I would suggest you to actually calculate it in not in kilograms, in grams only. That will be more better for you, right? Otherwise, you will get, keep getting confused here. So what I can do, I can just erase this and I can just write down my own explanation here, right? Because this now you might get confused here. So let's talk about this. See, you have one urea has one N2, right? Now, if you talk about one urea contains one N2, that means urea means 60 gram. 60 gram of urea contains 28 gram of N2, right? Now, from the question what we have, this much of urea contains 45%. That means 45 gram of urea. If 100 gram of, because they are saying this weight mass percentage, that means they are talking about weight by weight. So you can decode this. That means the solute is 45, the solution is, right, 100 grams. So you can say 100 gram of urea solution, right? Urea solution, right? This you can say here, right? Now, 45 gram of urea, if 100 gram of urea solution you have, now, or you can just write down urea because we are not actually mixing anything here, right? So, because we are talking about the total volume, this percentage also applies to, if you're talking about some specific thing divided by total, right, multiplied by 100. So, here they are specifying N2, right, and they are talking about this total. So, you can say 45 gram of N2 in, if 100 gram of urea is there. Now, this is from the question, okay? This is from the question you have, right? This is from the question. Now, what you need to do, you just apply unitary method. They are asking you actual urea content here, right? So, what you can write here, 60 gram of urea, right? 60 gram of urea has this much. You can say 28 gram of N2, right? Gives you 28 grams, 60 gram of urea, 60 gram of urea. Then you can say 1 gram of N2 will give you 60 by 28 of urea, right? Then they are discussing about how many gram of N2, how many gram of N2 you have here, 45, right? So 45 gram of N2 will give you 60 by 28 multiplied by 45 of urea, right? Calculate this and you will get your answer. Let's see who actually calculate this. I'll use calculator, but you will use this, right? Your brain. 96.4 we are getting, right? That is B. Okay. Answer you will get is 96.4. 96.4. Now you will see one thing here. Okay. You will see one thing here that the answer is given in kilogram, kilogram, kilogram. Ma'am, now do I have to convert it into kilogram? You don't need to worry about that. See, simple thing is it is weight by weight. Even if this is in gram, that will thousand will cancel out. Even if this is in kilogram, that will cancel out, right? So your answer, right? If they are asking the answer in kilogram, you can just, instead of gram, you can just write kilogram, kilogram, kilogram here. Everything is else is same because it is mass by mass. Eventually gram, gram, kilogram, kilogram are going to cancel only, right? So you can just write here kilogram, kilogram here, right? And the answer also will be in kilogram there. Okay, everybody understood, right? 96.4, that is B is coming out to be the correct answer here, right? Now, next thing is mole fraction. Next concentration term is mole fraction. So shall I start with mole fraction, everybody? Volume of solution here, why it's not in milliliter or liter here? Ma'am, the volume of solution here, why it's not, where is volume of solution? See, I told you solute, weight will be in grams, volume will be in milliliter usually, right? If in the question they are giving you this in kilogram, then you can take it in kilogram also, right? It's not a restriction that you have to take in grams or kilograms. That is not there. But in usual cases, because in solutions we take milligrams only, we don't, mix kilogram, 1 kilo of 3 kilo of sugar you are mixing, right? Usually we mix in labs, we mix in grams only. That's why usually it is taken in grams, right? Otherwise, you can take it in kilograms as well. But I would advise you, if it is not the requirement of the question, take it in gram. It was the requirement of the question here. That's why I converted it into kilogram, right? That was also, the value was same only, right? Okay, yes. Now, let's see what is mole fraction, right? Now understand one thing, mole fraction are of two types, right? Why two types? See this thing, when the beaker, right? This is the beaker, right? You have some volatile solute here. You are adding some solute or any compound here that is volatile, that is giving the vapors, right? So this is giving the vapors here, right? Okay. Now what you will see, some of the vapors are here as well, or some of the particles of the salts of that compound is here as well. Now, whenever I talk about mole fraction, that is represented by this X kind of symbol, that is called mole fraction in liquid phase. In this liquid phase, mole fraction is called, this is the mole fraction, right? But when you talk about mole fraction of these vapors, that is represented by this Y, and this is a very confusing part for most of the students. They usually don't and I, like, there are so many interesting questions that they ask me in NEET examinations regarding this only, because the level is going to increase now, and I have like very strong feeling that they will ask you some question with this confusion with this mole fraction of liquid and mole fraction of vapor phase. So whenever in the question it is mentioned that this is mole fraction, just don't directly put that this is the mole fraction. You have to see whether they are talking about simple mole fraction, that is mole fraction in liquid phase, or they are talking about mole fraction in vapor phase, because the formulas are entirely different for that, right? Here we are discussing about the mole fraction in the liquid phase. So mole fraction in the liquid phase is number of moles of that component. Let's say that you have 1, 2, 3, 4, or I have a beaker. I am adding how many components here? Let's say I am adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 components you have added here. Now, because you have added 10 components here, can you tell me one thing? If I discuss the mole fraction of third component, that will be number of moles of third component divided by total number of moles. That means N1 plus N2 plus N3 plus N4, so on up to N10. You have to add everything, right? But usually you will see only two components are added. One is solute, one is solvent. That's why when we calculate, let's say you have two components, okay? In that case, mole fraction of second is N2 divided by N1 plus N2. That is the total number of moles in this case, right? So if you have m or x number of moles, like you have 100 number of components, so you will add all the mole fraction of those 100 components that you have. This is very rare to happen, right? It's not possible, right? It's like you are like messing up with chemistry, right? So usually we add binary solution. Binary solution means which have one solute and one solvent, right? Now here, if you talk about mole fraction of all the components of 1, 2, all the components that is there in the solution, you have 10 components, so mole fraction of these 10 components will be equals to 1, right? Why I'm discussing about so many components? Because they can ask you in this way, right? So now let's see this here. In this, they are asking, they are only telling about 2 components, right? So if let's say mole fraction of A you have to find, that will be number of moles of A divided by total number of moles, Na plus Nb. B is mole fraction of B plus Na plus Nb. Now how come you have mole fraction of A and B as 1? So if you see mole fraction of A, mole fraction of B, what is this? This is equals to number of moles of A, number of moles of A plus number of moles of B. Number of moles of B divided by number of moles of A plus number of moles of B. So always it is going to be, this is take the LCM Na plus Nb, and here it will be Na plus Nb. It will cancel and it will be equals to unity. Even here if you discuss, mole fraction of 1 will be N1 divided by Nt, N2 divided by Nt, N3 divided by Nt. So can you write N1 divided by Nt, right? Nt means total moles, N2 divided by Nt, plus so on up to N10 divided by Nt. That will be N1 plus N2 plus so on plus N10 divided by Nt. Now Nt is nothing but addition of all of this. You cancel it, you will have 1. So always that's the reason the addition of all the components, the mole fraction of all the components is always going to be unity here. That is 1 here, right? I have also proved it in front of you so that you can understand this. You don't forget this in the exam, right? That is my main motto here, right? Now, this formula we have learned about the mole fraction in liquid phase. Now, to understand the mole fraction in vapor phase. Ma'am, you talked about mole fraction in vapor phase also. What is the mole fraction in the vapor phase, right? This is represented by Y, right? Now, this Y, how you will represent it, right? Mole fraction of A, mole fraction of B. That is a simple thing that in vapor phase, what you will say, number of moles of A divided by total number of moles of this. But these are the number of moles in the vapor phase, number of moles in the vapor phase. Here NANB is representing the vapors. Formula is same because it is also mole fraction, guys. Formula is same because it is also mole fraction, right? But here they are talking about vapor. This is also vapor. This is also vapor. This is also vapor. But in this formula, N1, NT, N2, N3, N4, N5, N10, these are the number of moles in the liquid phase. Is this clear to everybody? Formula is same for mole fraction in liquid phase or vapor phase, right? But here we are talking about number of moles in the liquid phase. Here we are talking about number of moles in the vapor phase. Is that clear to everybody? That thing is clear? Students, everybody, if that thing is clear, then let me know in the chat box so that I can proceed with the next formula here, right? Because otherwise you will get confused in the liquid and vapor phase, right? Now, students, if you see the next thing here, that is mole fraction in the liquid phase, mole fraction in the vapor phase. Ma'am, if the formula is same, one thing is, throughout your chemistry, to calculate the mole fraction, you will have different formulas. In Henry's law, you have a formula, this and that. But, right, if you see this here, in Henry's law, you will use mole fraction in the liquid phase, right? So, if you want to have a formula, how they confuse you in the exam, in the liquid phase, mostly you use this formula only. Throughout your chemistry, mostly you will use this formula only. Otherwise, you will see the formula in solution chapter in Henry's laws as well. But there also you will use this formula, right? In Henry's law, you have mole fraction of liquid phase. Now, talking about vapor phase formula, there is one more formula, that is, this is Y, This is PT. This is partial pressure. This you will discuss in the, this we will discuss in solution chapter. This we will discuss in solution chapter. When I will discuss Henry's law, there only I will discuss this. That in Henry's law, what you have, you use mole fraction, right? In Henry's law, this is the partial pressure. Partial pressure is equals to mole fraction multiplied by KH. This is Henry's law, right? I'll just write it here. This is, I think, given by Dalton, but here, where should I write it? Don't worry, we will discuss in detail in Henry's law, right? This is KH, this is mole fraction. Now, understand one thing, why I showed you this formula, because this is where they confuse you. This is the liquid phase mole fraction. This is the vapor phase mole fraction, and this is very, very, very important for you to understand so that you can solve the questions of solution chapter as well. Mole fraction of liquid and vapor phase is entirely different, and their formulas also different. Formula might seem same, but N1 and N2, N is resembling, is actually denoting some other thing only. In vapor phase, N is the number of moles in vapors, and in liquid phase, N is the number of moles in liquid. But the formula, if you see, this is the Dalton's formula, this is the Henry's formula, that is entirely different. Here, this is total pressure, partial pressure is KH into mole fraction. Okay, this we will discuss more in detail in the solution chapter. Okay, now let's see this here. The question is, a solution is prepared by mixing 30 grams of ethanol and 30 grams of water. Determine the mole fraction of each component. Right? Moles of ethanol only, that means liquid only they are asking you. Mole fraction, see, whenever simple mole fraction is written, that means they are talking about mole fraction in the liquid phase, right? Now, mole fraction of ethanol is going to be, if you talk about number of moles, okay, firstly you have to calculate the number of moles. Ethanol is what? C2H5OH. What is the molar mass of ethanol, students? What is the molar mass of ethanol and what is the molar mass of water? 18. Molar mass of ethanol is 12 multiplied by 2 plus 5 plus 16, or you can say plus 6 plus 16. What is the molar mass here? 24 plus 16 plus 6, right? 6 to 12, 12, 4, 16, 2, 3, 4, that is 46, right? Okay. है ना? 16 plus 6, that is 22, 24, yes, 46. Okay, so this is coming out to be 46 here. Now, if you see, number of moles of ethanol is going to be what? Number of moles of ethanol is 30 by 46, right? Number of moles of water is going to be 30 by 80, right? Now you see, mole fraction of ethanol is going to be 30 by 46 divided by 30 by 46 plus 30 by 18, and mole fraction of water is going to be, this is 30 by 18, number of moles of water, 30 by 18 divided by 30 by 46 plus 30 by 18. Or you can also solve it like this. Once you calculate the mole fraction of ethanol, mole fraction of water will be equals to 1 minus mole fraction of ethanol. By this also you can calculate. Is that clear? Okay, simple. Easily you can calculate this, right? Okay, yes. Now let us see the next question here. Wait a minute, right? So, next question is, 5.2 of methyl alcohol, this is supplied. What is the mole fraction of methyl alcohol? So I have also taken JEE mains previous year question, because you should also do the previous year question of JEE mains. That is mandatory from now, right? You can't skip that. NEET is important and JEE mains previous year question are also as important for you, right? Now, 5.2 mole, wait a minute, this is regarding molality. Right, this so I will not do here, right? This will not do here, right? Firstly, we'll discuss about molality. Molarity, molality, then we will discuss about this, right? Now let's discuss about some important terms like molality, molarity, normality, strength, right? Then we will discuss about that question, okay? Now, here it is molarity. Molarity is number. Now here unit plays a very important role. In percentage, ppm, I was saying that you can take it as gram or milliliter, it's not fixed, but here unit is fixed, right? That means this is number of moles of solute divided by volume of solution, and that will be in liter only, right? If you are not taking this in liter, if you are taking this in milliliter, then you have to multiply it by 1000, right? So if I write it easily here, right, you can say molarity is equals to number of moles means weight of solute by molar mass of solute multiplied divided by volume. If this is in milliliter, you'll have to multiply it by 1000. And this formula, this is a very, very, very important formula for you for your entire physical chemistry. This is a very important formula, right? Very, very important formula. Right, that's why these concentration terms, they are the base of physical chemistry, right? So molarity is equals to W2 by M2 multiplied by 1000 by volume of solution in milliliters, right? Now this is actually the interrelated you can say, if you want to, like, these are the interrelated relations, like weight by weight, right, related with molarity, weight by volume, what is the direct formula with molarity, right? This, I just tell my students that, okay, this is the formula. I don't advise them to like cram this formula, right? Because, you know, when you know the weight by weight percentage, right, easily you can calculate the molarity if you know how to decode this, right? So if you don't want to cram formulas, like too many formulas for you, it's difficult for you to cram, I would advise you, if you know the art of decoding, this formula is not required, right? But still some students hate, like, ma'am, I don't want to decode all of that, right? Decoding is necessary for you, you should understand. But if you want to, you are in hurry, you want to give your exam, like in, like, you know, say you want to save your time, then definitely if you have that mental retaining capacity, then definitely you can learn these two formulas. Otherwise, it's not that important to learn this. You can also decode weight by weight percentage, then calculate the value of molarity. I'll also show you some questions on that. Don't worry, right? Without using the formula, I'll do the question, okay? Now, let's see this here. Molarity, if it is given in the question and semi-molar, that means we are talking about m by 2. If they're talking about decimolar, that is m by 10. Centimolar means m by 100. And millimolar means m by 1000, okay? So all these things also should be on your tips. What is semimolar? What is decimolar? What is centimolar? What is millimolar? Okay. Now, next is, let's see this question here or not. Firstly, after molarity, I also tell my students to understand what is strength. Okay, you should also understand what is strength. After molarity, strength. Now, what is strength? Strength is same as molarity. The difference is, in molarity, what we used to say, number of moles of solute divided by volume of solution. Here what we are saying, instead of moles, you are writing weight. Okay, this is weight or mass of solute in grams divided by volume of solution in liters. That's it. So strength is equals to weight of solute divided by, directly you don't have to write it molar mass, divided by this will be your volume of solution. If it is in milliliter, this will be multiplied by 1000, right? So can I just write here, if this is molarity, so can I also convert it like this? Can I also write it like this, that molarity is equals to, this whole thing is nothing but this is strength. So can I write strength by molar mass of solute, right? So can you also write that strength is equals to molar mass of solute multiplied by molarity, right? This also becomes a very, very important formula for you, right? And in the questions, you know, you will see really good level questions I'm asking, I'm telling you. I'm not talking about very chintu mintu kind of questions, very good level of questions. What they give you, they will give you the concentration is this. What is in a student's mind? They say, it's a concentration, they are giving me molarity. But how they will play the game, right? Instead of, they will write the units as units of strength. Tell me, beta, what are the units of strength? Units of molarity is number of moles divided by volume, right? Number of moles does not have any units, right? That will be, this will be per liter, right? So you can say per liter, just directly per liter, right? But if you see this here, if you see this, that's why in molarity, in molarity we directly write molar. These are the units of molarity. Because if you see this here, the mass and mass will cancel out. It will become per liter or per milliliter only, right? But can you tell me what are the units of strength? What are the units of strength? Units of strength are, everybody, what are the units of strength? Units of strength are gram per liter. Reason, mass by volume. So whenever they have given you concentration of the solution, find the concentration of the solution. These kind of questions they have not asked in NEET yet, but very high probability that they can ask you in NEET 2026. Reason, because they have asked similar kind of questions in JEE, right? Because I also teach JEE, so I know that what kind of question they ask in JEE, which has a very high probability they can ask you here, right? So these kind of questions where they have just asked you what is the concentration, students will solve the molarity, but in reality they are asking you the strength, because in the options you will see gram per liter, and gram per liter is the unit of strength. That is also a concentration term, right? Okay, clear everybody? Students, is that clear? Right? This is what normality, molarity, molality, formality, all of them are same only, right? So that's why this is the confusing part of students, that everything is same. In fact, molality and molarity are like twins. Normality also has a very small difference, right? Then strength has also a very small difference. So there are very small differences in all of them, right? So they are like twins only, like not even twins now, right? I don't know, four same kind of people looking what they are called, right? Quadruples. Now let us solve this question here. How many grams of concentrated nitric acid of solution should be used to prepare 25 milliliter of 2 molar HNO3? The concentration, concentrated acid is 70% HNO3. Now, they are asking you how many grams of concentrated nitric acid solution should be used. That means they are asking you the mass. They are asking you the mass, right? Should be used to prepare this much liter. That means volume is given, molarity is given, molarity is given. The concentrated acid is 70% of HNO3, right? Now, firstly, what you should know. By this, you know that mass they are asking you, molarity you know, volume you know, easily you can calculate the mass of the solute. But they are not asking the mass of the direct solute. They are saying that it is a concentrated nitric acid solution which is 70% of HNO3, right? Molarity is given to you. So that means that 70% you have to also take care of that, right? That means if you see this here, in this beaker, they are saying 30% is water, right? And this 70% is HNO3, right? Okay. How many grams of concentrated nitric acid solution you should use to prepare this thing, right? Molarity after mixing this water, right? First, you have to see that what is the question they are asking, telling you. They are saying that you have a beaker, you add acid here, right? 70% acid you are adding, 30% water you are adding, right? Now you want to make the molarity as 2 molar, but the overall solution should be 250 milliliter. Now this is the 70% acid, right? That means it is not fully, right? So here what you should do, okay, let's solve this. I think firstly the question is clear to everybody. What is there in the question? Mass, then mass identification, then do 70%. Very good. Very good, very good, very good. Very good. Thank you so much, beta. Very good. Yes, it's live only. It's live only. Please tell me MCQ. Yes, MCQs only I am doing here, no? These are MCQs only, right? So let's solve this here, okay? Let's solve this here. First thing is, this is the formula of molarity. Molarity, you know, right? Molar mass of HNO3, you know. Volume of the solution, you know that this is 250 milliliters, they are asking, right? Now, from here, can I find the weight of HNO3, right? Weight of HNO3 now I have. And they are saying that 70% of that you have to use, right? So weight of HNO3 you have 70, mass of acid multiplied by this 70% is going to be this much thing, right? So now that means what I used here, this is coming out to be 63 by 2. And this is 70% of mass of acid. So in that way, I can calculate the mass of actual acid. Is this thing clear to everybody? What we are doing here? We have a beaker. We are saying that we are adding 30% water and 70% we are adding HNO3. Right? Okay. Now, total solution will be 25. And here, this solution, if you're saying that after doing this, the molarity is becoming 2 molar. Right? So now, we are given with the volume, we are given with the molarity of this solution. Firstly, we have calculated the mass, which is coming out to be 63 by 2. Now, this mass that I have calculated, what was this? That was nothing but that was 70% of HNO3. That's what I have written. Mass is 70% of mass of acid. That is mass of HNO3. And that's how I can calculate the mass of HNO3. Is that clear to everybody? Right? These kind of questions are very important for you. Right? I am not picking basic questions here. I know that you can easily do basic questions, right? It's very easy to put the formula, right? Get the value. It's not a big deal, right? What you want here, why you are here for good questions, okay? That's what I have picked up, right? So this is how you will calculate, and these kind of questions they ask when there is some good level of NEET exam is there, then they ask these kind of questions, right? So that you must know. I think these you can easily do, right? So that's how answer will be 45 gram of HNO3, right? Next question is the density of 3.6 molar sulfuric acid solution, that is 29% of H2SO4, right, by mass will be. Okay, now what they have given you by mass, that means they have given you what they have given you, mass by mass percentage. Can I say that that means weight of H2SO4 is going to be 29 gram and weight of solution is going to be 100 grams. Firstly, let's decode this thing, okay? Then the density, can you see here what they are asking? Acha, density is this. Density of this much will be. Okay, density they are asking you. Density, for that we need to find the mass, we need to find the volume, right? Of this much molar sulfuric acid solution, that is this H2SO4 by mass. Okay. Now, can you calculate the volume here? Can you calculate the volume, or you can easily put it here, or you can easily solve it like this. Molarity is equals to weight of solute by molar mass of solute multiplied by volume in milliliter, right? Multiplied by 1000. And what is density of solute? Density is equals to mass by volume, or you can say W by volume, right? So can I just, do I need to calculate this thing actually here? Why to do that much of hard work, you know, when you can easily solve it like this? Volume of milliliter, this will be molarity, molar mass, right? In fact, that was also not needed then though, right? Because they're asking you mass will be, right, this will be divided by 1000. Let me just see. Molarity is 3.6, right? 3.6 multiplied by molar mass of H2SO4 is 98 divided by 1000. Let me just see if you're able to get the answer, because it's a shortcut that should be applicable here, right? 0.35. It is not coming out to be in any of the options, right? The density of this much molar sulfuric acid, that is 29%. Weight of solute is that, right? 29% by mass is this. So now let's, 29% means weight of H2SO4 is that, weight of solution is 100 grams, right? This is given to be density only they're asking, 39 into this. Then if it is not, I don't know why it is not coming out like this. Wait a minute. It should be 3.6 multiplied by 98. Milliliter only they are saying, na? Gram per milliliter. So let's see what is the other way. The other way is that this is given to be 29. Okay, let's do this. Okay, let's do this. I just did a shortcut. Okay. Molarity, this is W2. This is by M2 multiplied by volume in milliliter. This is multiplied by 1000. I think that is because 29% is given. Na? That is because of that. Because if you see the weight here, weight you can put here, that is 29 multiplied by 1000 divided by 98 multiplied by volume in milliliter multiplied by, this is 3.6, right? So you can calculate the volume in milliliter, right? This is 3.6, you can divide it by 3.6, right? Now let us see if we are able to get it or not. This is the volume, right? Mass by volume, right? Even now if you calculate this, this will be density is equals to mass by volume. The density of this molar acid, that is 29% of H2SO4 by mass. Okay. Mass is given to be 29, then also it is coming out to be the same. No? Volume is 29 multiplied by 1000. This is 3.6. This is 98. That is coming out to be the same thing only. Let me see why. What wrong we did? I don't want to solve it by direct formula method. No, that's why I'm looking at this 29, that is weight of solute, right? That should be that way only. Molarity wrong, right? I think there is some kind of maybe this question is then not right, because it should not be like this. Because when, if you're not solving it with the help of the direct formula, then it should be, because what is mass? Mass is, what is density? Density is mass by volume, right? This is mass and this is volume, right? So that is density only, right? Let's see what is happening here. Let's see, even this is density, right? This is M2 and this is 1000, right? Density is mass by volume only, then density will be in gram per milliliter, right? This is in milliliter, that's why I multiplied by 1000. This is molar, this is molar mass, right? That is the density. So density is going to be molar mass multiplied by m2 divided by 1000, right? This is how it is coming out to be, right? So I think something is wrong in the question, okay? Right? Okay? Okay, because I am trying to solve this without any formula. For that, if that is not happening, then something might be wrong here. Right? Okay? Chalo, let's then not do this. Right? Because by formula, so easily you can solve this. That's not a big deal. Formula you have here. Molarity is equals to 10 into D into weight by weight divided by molar mass of solute. But why we are not able to solve it like this? Right? That should also be there. Isn't it? Do you agree? Hmm? Chalo, we will leave this. Okay, we will leave this. You can do this with the formula, but without the formula, I was thinking how to do this. That's why without the formula, it's getting little bit confusing to do this question, right? Because that will be density by this, right? Chalo, let's do the next one. Okay, let's do the next one. That is calculate the total molarity. Now they're asking total molarity of all the ions present in the solution containing 0.1 molar CuSO4, 0.1 molar. Now total molarity, whenever is given to us, two things are given to us, right? Now how to calculate the total molarity of the ions? Calculate the total molarity of the ions present in the solution containing 0.1 molar, and this is CuSO4, 0.1 molar Al2 this, right? So now see, whenever two things are given to you, right? First, you need to understand the formula of mixture, and that is different, right? Here they are saying that these ions are present 0.1 molar of Cu2 positive, SO4 2 negative, and Al3 positive, 2 Al3 positive you have, right? And SO4 2 negative you have 3 then, okay? And that's how you are getting the molarity as 0.1. So you have to calculate it for individual ions. How you will do that, right? So first is CuSO4, that is given to be 0.1. This will also be 0.1. This will also be 0.1. Okay. Then you have Al2SO4. This is 0.1. Then this will be 0.2 because 2 into 0.1 is 0.2. This will be 0.3 because that will be multiplied because concentration is multiplied, no? So these are 2 ions, so it will be multiplied by 2. These are 3 ions. It is 2 ions, this is 3 ions. So it will be multiplied by 2, multiplied by 3 here. Now you have to add all of that. Cu is 0.1, add 0.1, right? SO4 is 1, 3 here you have. So what you will do, you will add all the possible SO4 2 negative molarities. That is 0.3, this is 0.3, I'll just write this is 0.3, this is 0.1, I'll add 0.1, and this is 0.2. Okay, so I'll add 0.2, and that's how you will get answer as 3, 4, 5, 6, 7.7. Right? Now, here they had given you simple question regarding, wait a minute, right? So that is going to be 0.7, right? Not this, right? So answer is going to be 0.7. Now, this was not the question regarding the mixture. They were just telling that you have these ions, you have to identify the molarity of different ions. But when we talk about the mixtures, then there is a different formula for that, right? Now, calculate the mass of NaCl required to produce 100 milliliters of semi-molar solution. Semi-molars, tell me what is that? Semi-molar, what is that? Semi-molar means 1 by 10, right? That is m by 10 molar, 0.1 molar is they are talking about. Volume is given to you, mass of NaCl you have to calculate, right? So now molarity is m by 2, m by 10, that is 0.1 molar. You can also write it as 0.1 molar, right? Now volume W2 you have to calculate. M2, what is M2? Na is 23, Cl is 35.5, so that is 5, 5, 6, 7, 8, 58.5. So M2 is 58.5 multiplied by 1000 divided by volume in milliliter. Volume is given to be 100 here, right? So put all the values and you will get your answer of W2 here. That is going to be 0.1 multiplied by 58.5, right? And this is 10. It will come to this type, that is 10. Okay? And hence you will get your answer here, right? Okay? Yes, everybody, right? Understood? This is, I don't know. Deci was, Deci was 1 by 10. I'm so sorry. Right? Deci was 1 by 10. Deci was 1 by 10. Centi was 1 by 100. And milli was 1 by 1000. Right? Semi was 0.5. So sorry. Semi was m by 2. Right? So that's why it will be m by 2. That is 0.5 molar. Right? That will be 0.5 molar. Then here you will have 0.5. And that's how you will get the answer, right? Semi was 1 by 2. Half of this, na, semi sphere you talk about, hemisphere you talk about, that is half of that, right? Deci was 1 by 10, right? Now, let us see the next question here. That is, calculate the concentration of Na positive Cl negative when 200 milliliter of this much Na is mixed with this. Now, for this, you need to know this formula, that whenever you mix two things, right? Whenever you mix two things, that is M is going to be, total is going to be M1 V1 plus M2 V2 divided by V1 plus V2. And this is the formula that you have to apply here. Calculate the concentration of Na positive and Cl negative, right? When 200 milliliter of this much NaCl mixed with this much of CaCl2, right? Now, firstly, what you should know, two things are mixed together, right? And they are asking you to calculate the concentration of Na and Cl. Now, this is very important because they are specially asking you to calculate the concentration of Na and Cl only when all these things are mixed together. And if you see that Cl and Cl is the common ion here, right? So we can't just directly put the formula here, right? We will solve this with the help of equations. Like you have NaCl will dissociate into Na positive plus Cl negative, right? And you will have CaCl2 that will dissociate into Ca2 positive plus 2Cl negative, right? That's how it will dissociate. And from that dissociation, because this is 200 milliliter in 0.1 and this is 300 milliliter of 0.1 CaCl2, this is what you are going to add here. So for that, we will firstly mix this, right? We can calculate the number of moles here, right? We can calculate the number of moles because we know that if molarity is equals to number of moles divided by volume in liter, right? If you are putting this in milliliter, if you are putting the volume in milliliter, then this number of moles will be millimoles, right? If this is the milliliter, this will be millimoles. So can I firstly calculate the millimoles here? Like 200 multiplied by 0.1 millimoles, that means NaCl will have 200 multiplied by 0.1, that is, it is going to be 20 millimoles. This is 20 millimoles, this will be 20 millimoles, this will be 20 millimoles. CaCl2 will be 30 millimoles, right? So it will be 30 millimoles, this will be 30 millimoles. Now they are saying that concentration of Na and Cl. So Na is how many millimoles? It is 20 millimoles. So molarity is going to be millimoles divided by total volume, that is going to be 500, 300 plus 200, right? Total volume is 500 now, right? Millimoles of Na are 20. This is going to be your molarity of Na positive, right? This is going to be the molarity of Na positive. Can you tell me what is the molarity of Cl negative? Molarity of Cl negative. How many millimoles of Cl negative you have? 20 plus 30, that is 50 millimoles you have. And the volume is 500, that is going to be the concentration of Cl negative here, right? So You have to see that in the mixture also what kind of questions they are asking you. Do you need to apply this formula here or not? So M is equals to M1 V1 plus M2 V2 is not applicable here because they are dissociated into ions. So you have to do it with the help of ions only, right? Okay. Understood? 20 by 50, 20 by 500, this will be 500, right? This Cl negative 80, wait a minute, why it is 80? I don't know why I'm doing silly mistakes today, right? I think my brain is some other zone only. This is 1, so this will be 1, this will be multiplied by 2, so this will be 60. 60 plus 20, this will be 80 by 500, right? Okay, silly mistakes. I don't know why I'm doing this today, right? I think your energy is low now, so that's why my energy is also getting drained, right? That's why my brain is working slow today, right? So that's how you're going to calculate the, without applying the formula, you will calculate for ions, right? Now, let's see what is molality, right? And this is the formula of strength. Strength equals to molarity multiplied by the molar mass that I have already discussed with you, right? Now, one more thing I think that we are left with is, firstly, let's do dilution here, right? First, let's do dilution. What is this question? To calculate the molarity of a solution when the solute is given in grams and the volume of solution is given in milliliter, you must firstly, now to calculate the molarity of solution when solute is given in grams and volume solution is given in milliliters, what you have to do? Tell me. Convert grams to mole, convert volume of solution of milliliters to liters, but leave grams to moles, convert grams to moles, and convert volume of solution in milliliters to liters. What you have to do? You have to see if molarity of a solution when the solute is given in grams, right? Then you have to firstly convert it into moles. Then also you have to convert milliliters to liters, right? That means C is what you have to do, right? So answer will be C. Now, for dilution, what you are doing, right? Dilution means you are adding water into it, right? So you have a beaker M1 V1. You add water into it. What you have to do when you are adding water, right? So now understand one thing, when you're adding water, molarity will change. Why? Because you're diluting it, right? Second thing is volume will also change. So the final volume, right, it is V2 and initial volume is V1. Initial molarity is M1, final molarity is M2. And what you will see that M1 V1 is equals to M2 V2 for a dilution case. Right? So moles before the dilution will be equals to moles after the dilution. Can you tell me why? Can you tell me why the moles are equal? See, simple thing is, this is the beaker, right? Here you have these many particles, right? Right? Okay, so I am drawing only 4 particles. Okay, I have 4 particles. Now it was up to this much, right? Now I am diluting it. I am diluting it more. I have added water. Now I have not added any particle of that solute. So that particle of the solute will be same only. Right? That will be same only. So that is the reason we are saying that number of moles before the dilution is equals to after the dilution. Right? So number of moles is what? Molarity into volume. That's why M1 V1 is equals to M2 V2. This is a very, very important formula in your practical chemistry as well. Right? Okay? Right? So next is mixing of 2 solutes. Now in mixing of 2 solutes, what you have to remember that when you are mixing 2 solutes, right? When you are mixing 2 solutes, the formula that I told you, right? That is M1 V1, right? That formula, same formula, that is capital M when you mix 2 things, M1 V1 plus M2 V2 divided by V1 plus V2, that is the total volume here, right? Okay, understood? The molarity is M1 V1 plus M2 V2 divided by the total volume that you have. You can just directly apply this formula when you have a mixture, when you're adding 2 things. But take care of that it should not be in ions form. Okay. So now let us see this question. two solutions of a substance are mixed in the following manner: 450 milliliter of 1.5 first solution and this much of second solution. What is the molarity of final solution? Simple, right? This is your M1, this is V1, this is V2, this is M2, right? So just put this here. M1 is 1.5 multiplied by 480 plus 520 multiplied by 1.2 divided by, two solutions are mixed, right? So divided by 480 plus 520 here, and you will get the formula molarity, right? Okay, this is all you have to do here, right? Next question is, because more questions you need here, you can't just cram the formulas, right? How much H2O should be added such that 200 milliliter of 2 molar becomes 0.2? See, simple thing is that, can you tell me what is given? How much H2O? This is a case of dilution. This is a case of dilution. Okay, that you should understand. Which formula to apply, that is a big deal, right? How much H2O should be added such that 200 milliliter of this, if this is V, this is M, should become this. I am saying that this is M1, this is V1, this is M2, right? So M1 V1 is equals to M2 V2, right? V2 is how much water you are adding after this, right? So can I say one more thing is very important. How much H2O? Simple thing is, one more thing you should know, that this is V1. V2 is equals to V1 plus water. You can't just directly apply the formula and get the answer. You should know what they are saying in the question, right? When you add water, right, V of volume, then you get, that is, then this becomes equals to V2, right? That means what you should remember, that M1 V1 is equals to M2 into V1 plus V of water. V1 of V of water. It's not V2. What is V2? V1 plus V of water. So M1 is given to be 2 molar. This is 200 milliliter. M2 is given to be 0.2. V1 is given to be 200 plus V of water. And that's how you will get the volume of water here after solving this. Right? Okay? Okay? Understood? Yes, everybody? Okay, sure. Now, that is, okay. Now, next is, this you can easily do, right? Now, 1800 you are getting it. That's great, right? Sure. Which doubt you have? Which doubt you have? But you can easily solve this, na? Which doubt you have here, right? It will be 400, right, divided by 0.2, 200 plus V of H2O, right? This will be 1000, this will be 2000, right? So it will be 2000 minus this, it will be 1800 volume of H2O, right? I have directly solved this, right? In this, they have firstly calculated V2, then they have solved it, right? So you can directly also do this, right? Okay, yes. Now, next is molality. Now, what is molality? It is also same as molarity. In molality, what you have here is number of moles of solute divided by weight of solvent in kilograms, right? Weight of solvent, right? This is what you have. In molarity, you had volume of solution. Here you have weight of solvent, that is the difference, right? And if you see, this is lity, that was molarity, right? And this is independent of volume. That is why this is independent of temperature. This is independent of temperature. All the concentration terms that are dependent on volume will be dependent on the temperature. Because this is independent of volume, this is independent of temperature as well. That is number of moles of solute by weight of solvent in kilograms. Let us solve this question here. That is, calculate the molality of KCl solution prepared by dissolving 7.45 gram of KCl in this much of solution. Given density of solution is this. See, calculate molality. Molality will be highly used in your questions, right? If you put this in grams, then you multiply this by 1000, right? Now I have put this W1 in grams. That's why I have multiplied this by 1000. Now what we are saying, calculate the molality of KCl solution prepared by dissolving this much of KCl. This is the W2 that you have, right? In 500 milliliter of solution. See students, density is equals to mass by volume. Mass is equals to density into volume. Density is what? Density is given to be 1.2. Volume is given to be 500. This is gram per milliliter. This is milliliter. So the answer will be in gram. This is the mass of solution or what? Right? This is the mass because volume of solution is given. Density of solution is given, means this is the mass of solution. Right? Mass of solution. Now, weight of solvent is given to you, that is 7.45. So mass of weight of solvent will be equals to weight of solution, that is 1.2 into 500 minus 7.45, that is the mass of the mass of the solute, right? So when you solve this, 1.2 multiplied by 500, 600 minus 7.45, that will be 592. 592.95.55, right? That will come out to be the mass of solvent, because here they are asking the mass of solvent only, right? They are asking you the molality. So what will be the answer? Answer will be W2 is what? W2 you can easily write. W2 is what? W2 is weight of solute, right? Weight of solute is given to be 7.45. 7.45 multiplied by 1000 divided by KCl. You can put the molar mass of KCl here, right? Easily, right? Then this weight of solution you will put 592.55 and you will get the answer for molality here, right? Okay, you will get the answer for molality. You can easily put all of these, right? You will get your answer here. Put this, you will get the answer. Okay, yes. Next is, which of the following is dependent on temperature? For this is a question of 2017, right? Now, which of the following is dependent on temperature? The one which is dependent on volume. This is dependent on volume. This is not dependent on volume. Weight is also not dependent on volume, right? Molality is also not dependent on volume. That means molarity is dependent on volume. So that is why molality is dependent on the temperature. So answer will be A, right? Okay, understood everybody, right? So whenever temperature changes, molality is also going crazy here, right? Okay, everybody, right? Keep this in mind. Molarity and molality are different, right? Molality, we talk about weight, right? Molarity, we talk about volume. Here we talk about weight. It changes with temperature. It does not change with the temperature, right? Okay, understood? Now, this is the relation of, this is the important relation. This I would advise you to learn, right? Why? Because sometimes they give you molarity, they ask you molality directly, right? So that thing is very complicated if you don't have any formula. So this I would advise you to learn the formula directly and solve this as it is, that is given to you, right? Okay, molality and mole fraction relation, this also, this is totally your choice. It's not that important, but I would advise you to learn this formula because might be in some questions, right? Easily you can solve the answer without too much complications, but it is not a very repeated formula, right? So I would put only 1 star here, but this is a very, very repeated formula, right? So I will put 3-4 stars here because this is important, right? Okay. Now, I think I would like to give you this for your homework, right? So I'm giving you some questions. This is for your homework, okay? So I am giving you this for your homework, right? Let us see how many of you are able to do this. This is for your homework, right? Let us see. Mole fraction of solvent in aqueous solution of solute is this. Molality of the aqueous solution. Direct formula you have to apply. Direct formula, right? This is a formula based question. Directly you have to put the formula and get the answer. Let us see who will tell me the answer in the chat box. I'll see the answer in the comment section. How many of you are able to answer this in the comment section? Let's see that, right? Now the last one is regarding normality. That is, you will use this mostly in electrochemistry, right? So what is firstly equivalent weight? Equivalent weight is molar weight divided by n factor. And here, what is n factor? That we will study before electrochemistry. I'll take up a lecture on n factor specially, right? So n factor is, if you want to know it in simple terms, HCl gives 1 H positive, so n factor is 1. H2SO4 gives 2 H positive, so n factor is 2. KOH gives 1 OH negative, so n factor is 1. CaOH twice gives 2 OH negative, so answer is 2, right? So n factor in the simpler way is this, but actually it's a very variable topic that might change when you have salt, when you have different cases. When you mix something, then the n factor may change, right? So depending upon that, we will take up a detailed lecture on n factor, but for now you can just understand this thing. This is called n factor, right? So molar mass divided by the valency factor, that is called the equivalent weight. Now n factor, like for an element, this is the valency. For an ion, it is charged. Acid, it is how much H positive it is releasing. Base is how much OH negative it is releasing. And salt is what is the total negative and positive charge. Like you have NaCl, positive and negative charge is 1. So n factor is 1. If you talk about La2SO4 thrice, if you see Al, this is 2, this is 3 positive, this is SO4, 2 negative, this is 3. Can you see what is the, can you see 3 into 2, 6, 3 into 2, 6. So the total positive and negative charge will tell you the n factor in case of any salt, right? Don't worry if you're not able to understand this. I'll take up a detailed lecture on n factor, right? Okay. Now, where it is used? First is normality. It seems like same as molarity. Like normality is number of equivalents. Like we have used molarity as number of moles divided by volume. This is number of equivalents divided by volume of solution. Replace number of moles by number of equivalents, that is normality, right? Now, what is number of equivalents? We have studied that number of equivalents is equivalent weight by, not equivalent weight, you can just write it here, given weight by equivalent weight. What is equivalent weight? Molar weight by n factor, right? So that's why normality will be equals to number of equivalent is weight by equivalent weight. So that will be W weight of solute multiplied by n factor divided by molar mass, right? Okay, understood this thing, students? What we are saying, that if you talk about normality, replace moles by equivalent. What is equivalent? What is equivalent? If you want to, understand this in a better way, see, if you say normality is number of equivalents divided by volume. This is the volume of solution, right? Now this is in liters, right? So what I'll do, what is number of equivalents? That is weight of solute by equivalent weight of solute. Weight of solute by equivalent weight. What is equivalent weight? Molar weight divided by n factor, right? And this is 1 by volume in liter, right? So we can say that this whole thing is nothing but this is molarity, right? So we can say normality is equals to molarity multiplied by n factor. Okay, understood? So now you know the relation of strength is equals to molarity multiplied by molar mass, right? These are the formulas that will directly help you. How molarity is related to normality, how strength is related to molarity. These are the formulas that will directly help you in like a lot of ways, right? Now, what is the formula? What is the relation between strength and normality directly? Like we know that strength is equals to molarity into molar mass, right? Similarly, strength is equals to normality into equivalent mass. That is molar mass by n factor. Why it is so? Tell me why it is so. What is molarity? Tell me what is molarity? Molarity is equals to normality divided by n factor. Can I say what is molarity? Normality by n factor. So you put it here, normality by n factor multiplied by m2, right? That is going to be the answer. What is this? This is equivalent weight. So normality into equivalent weight, that is called the strength. That is your next formula, right? That is your next important formula that you are going to use in physical chemistry, right? This is the base of physical chemistry that I am teaching you, right? Now, this is like they're asking you one very important thing, that is normality of the following. This is molarity and this also molarity is given to you. You just have to multiply molarity with the n factor. Can you calculate that? What is the n factor of NaOH? What is the n factor of H3PO4? You know, n factor of H3PO4 is where students get stuck. Here you should also know the inorganic chemistry. If you see inorganic chemistry, I'll teach you, right? PO you subtract here, there will be 3 OH. So it is not able to release, it does not have any pH bond here directly, right? We need to have pH bond here, right? We need to have pH bond here. Anybody? If you talk about this here N factor is 1. What about H3PO4? I have already drawn the structure for you as well. Can you see that how many H positive we can get can be released from here? H3PO4. How many H positive can be released here, right? So if you see this, in this case, n factor is going to be 1, right? So this is point this, right, multiplied by 1, right? That is the n factor. That will be your answer, right? If you see, this is the molarity, right, in the B case. And how many H positive are being released here? 3 OH you have here, right? So multiplied by 3 and you will get your answer here. Wait a minute. 3 equivalent, na? You have this. Okay? This is 0.0 this multiplied by 3 and you will get the answer, right? So I have already drawn this for you as well so that you're able to understand phospho-oxo acid. This we will study in P block. Okay? This we will study in P block. That's why I told you I'm going to take up a full lecture on n factor so that these things you don't get confused, right, very easily, right? Okay? Like here you have, in the following reaction, calculate and find the normality when 0.1 molar H3PO4, right? 1 molar H3PO4 you have, right? Calculate and find the normality they are asking you. Right, 1 molar H3PO4 you want to have here. Right, this is the reaction that is given to you. So now, students, for this again you should know the n factor here. What I would advise that n factor we will study in a different lecture only, because otherwise this will get more complicated for you, nothing else. Right? So I would not want to teach you here n factor, right? Because things will get complicated. I can see that in the chat box you are getting like, what is n factor, ma'am? Right? N factor is a different topic, right? It is related to normality in a very high sense. If you know molarity, you multiply it by n factor, you can get normality, right? But n factor is also useful in electrochemistry that you are going to study in your class 12th, right? So that's why I'll take up a different lecture on n factor where you can understand n factor in detail. I'll take up different acid, bases, salts, mixtures, right? When you add strong acid, strong base, weak acid, weak base, what exactly happens there, and how to calculate the n factor, because that question was related to a reaction. Okay? Understood? Yes. What is volume strength? Arey yaar, don't worry, we will do that in redox reaction. Okay? We will do that in redox reaction. There are so many things that we are left with, but we will do that in redox reactions. When I'll take up the lecture of redox reactions, you watch it there, that will be more clear to you, right? Okay, yes. Molarity of solution in liquid state changes with temperature. The volume of solution changes with change in temperature. See, molarity changes with temperature and volume also changes. Both are correct and A is the correct explanation. As I told you that only those things that are dependent on volume are also dependent on temperature. That means if volume changes, volume will change with temperature, and because molarity has volume, that's why it is changing with temperature. And if you ask me why molarity changes with temperature, because it is dependent on volume, that also changes with the temperature. So answer is going to be A is the correct answer here, right? Okay, that's it, students, for today, right? And very, very important thing for all of you here, that is, I have given you one question for homework, right? Everybody, I have given you one question for homework. I'll just give you that again, right? Okay, so everybody, take the screenshot of this thing, take the screenshot. I want all of you to solve this question and give me the answers in the comment section. Give me the answers in the comment section. I want to see that if you're able to see do this or not. And one hint will be, you will use this formula here. Okay, formula also you take the screenshot. I'm giving you the formula as well so that you can answer this, right? Easily, I think you can answer this, right? Okay, you promise me that you will answer this or not. Right? Okay. Yes, everybody. Chal. That's great. That I would love to see that you guys are also doing your homework. Otherwise, this is a wastage, right? Otherwise, you'll be like, ma'am, we wanted to do the, like, ma'am, we are very serious, but we are not able to do the homework, right? I don't understand that concept, because when we are teaching the DNA batch, right, I don't even have to tell the students again and again that you have to do homework, you have to do homework, right? They do it themselves only, right? So in the DNA batch, we also provide quizzes, right? Leaderboards to the students, mock tests, everything students are doing, right? Everything you are doing. And can you imagine your competition, right? You are right now on YouTube, right? A lot of things are going there in DNA batch. If you're not able to complete even what is given on the YouTube, at least one question of homework, then I don't understand that what is this dream, you know? Then your dream is, I think, just daydreaming. You're not working hard for your dream, right? So for that, if you start doing the homework, I'll give you more homework questions, right? To more practice will be there, more questions will be there, more mistakes will be there, but you can know your weakness and you can cover up those mistakes, right? And students, this is our official Telegram channel. You can just scan this, and all the information regarding our live classes will be on the Telegram channel. And all the students who are looking for, like, ma'am, you're talking about DNA batch, but ma'am, where is that DNA batch? So students, here you can see in the description, right, that is DNA NEET batch 2026. Click on here, and this is a batch that is right now available at 4999. The classes are going on, right? And we are right now at structure of atom and other, it's not only structure of atom, side by side we are doing other chapters also, right? So daily the classes are going on, 3 classes daily, right? And you know, students also give the mock test, right, after every 15 days. Test series are also provided, tattva books are also provided. Like, it's like a lot of practice material that is provided to you that you can do. That means everything we are providing you, but now it's up to you that you want to do or not. And if you're like, ma'am, I can't do things on my own, I need someone out there to, you know, have a check on me, then our offline centers are also there, right? You can see this is where our offline centers are located all over India. And if you're a dropper, we are also providing you rank improvement guarantee. If it is not there, we will give you 100% fees back, right? And ma'am, I don't have like enough financial resources, then ma'am, what should I do? I can't afford the fees of offline, right? For that, we have 90% scholarship for you. Up to 90% scholarship you can avail here by giving IV SAT program, right? So now IV SAT program test is a scholarship test here. You can see this in the description box here. right? You will click on here, Reignite here, just click on Explain Offline Center, book a visit now, right? Click on here and register yourself to the offline centers. Once you are registered to the offline center means offline center IB-SAT program, right? That I would advise you to give it in the offline form. That means go to the coaching institute of Vedantu and then give the test, meet the counselors, meet the team, right? Your teachers. And you can also tell that I am a student of Vedantu NEET English, right? And you know what will happen after this if your results are really good. This is I am especially telling the droppers, right? Why I'm telling especially for droppers? Because you have already gained a lot of knowledge. That means you can easily do good in your IB-SAT program. If in that you're doing good, that means you can get good scholarship, right, in the offline centers as well, right? And the scholarship is applicable for offline, online, both of them, right? Offline JEE and NEET repeater batch we have already started, right? Okay. Yes, everybody. Chal. Now that's it for today, and I'll wait for your comments in the comment section. And what you have to comment here, tell me. You have to do your homework. You have to do your homework in the comment section. You have to tell me A, B, C, D, whatever is the answer that you are getting. Right? Any question for today, students? Any question by I'll before ending the class? Any question? Okay. Okay, GXDL, that's actually a good score. 530, 523 marks is a very good score comparing the exam that you had, right? So don't get disappointed. That means whatever you worked really hard for, right? You got what you deserve, right? Okay. Maybe more marks you were expecting, but what to do, na? The physics paper was very hard, so that's why the marks got low, right? Yes. Okay then. Okay then, students. Bye bye. Bye bye, students. Take care. See you all in the next class.